today's video, we're going to learn about slope, because kids don't like slope. And as I don't have graphing stuff on my board, I'm going to make up the graphs, so they're not going to look amazing, but they're still going to look okay. So first of all, we need to know what slope is. Slope is just the rate of change in something. It's kind of nice. And there's a easy formula to find out slope when you're given 2 points. So let's give ourselves 2 points. So I'm going to give myself 2, -3, and 4, and 5. 2, 3, 4, 5. Okay, that's fine. Okay. So knowing that, I have to do the formula is the change in y. So y1 minus y2 over x1 minus x2. So we know when we're looking at coordinates that the ones in front are my x's and the ones in the back are my y's, right? We should know that. So we need to choose which point we want to be our y1, and then we stick with it. That's the key here, is sticking with it. So usually I like to keep my slopes positive as if I can. So in this one, I see I have a negative y here. So I kind of want to leave this one as my y1. So if this is my y1, this is also my x1. So this would be my y2, and that's my x2. So now that I have that, I'm going to plug it into this equation. So I'm going to do 5 minus a -3 over a 4 minus 2. So now we see here we got 5 minus a -3, which is a double negative, which in math, 2 wrongs make a right. So I just draw a little line here. And now it's +3. So 5 plus 3 is 8. 4 minus 2 is 2. And then what's 8 divided by 2? Our slope of this line would be 4. And you can leave it as 4, or some people like to do this to it. Because if they're going to be graphing it, some people like to have a fraction, so 4 over 1. Really doesn't matter, because that's the exact same thing as 4. I like to leave it as 4, but that's just me. So, let's do another one. One that won't work out as nicely maybe as a fraction. I'm just making stuff up. So, okay. So looking at this guy, I'm like, which one do I want to use? So, I'm going to use this as my y1. So I'm going to do 7 minus a -8. And since I had this as my y1, this has to be my x1. You can't just flip it, because if you do, you're going to mess yourself up real bad. Done that before. So now we have to do 7 plus 8, because it was a double negative. 7 plus 8 is a number. Simple math. Simple math does not compute in my brain, because my brain injury is not doing well today. 7 plus 8 is 15. So 15, and then it's -6 minus 13, which is basically 6 plus 13, but keep it negative, which is -19. We can't simplify this, so if we were to graph this on a graph, which this one would suck to graph, because we'd have to go down 15 spots and then over 19. That is a steep line. So that is our slope for this one, -15 over 19. So now let's discuss what happens when it's a negative slope and when it's a positive slope. So this one was negative, and the last one was positive. So negative slopes, think of your graph as like a roller coaster. That's what I like to think of it as. So So we're thinking of it as a roller coaster. I'll erase it. I'm going to pretend to draw a graph here. I don't know what's happening on my phone. Hang on. I'm going to ignore it. It's my son. I can't talk to him right now. I love him, but he calls me for no reason. Okay, so let's think about this. We have our graph right here, right? This is our y-axis. This is our x-axis. Let's think of it as a roller coaster, right? So if we have a positive slope, we're going up the roller coaster like this. Whee! We're going up the hill. That's a positive slope, right? But we have a negative slope. We're going down the hill. It's falling down. So when you see a positive slope, that means you're going up the hill. See a negative slope, you're going down. That's pretty much it. Also, another thing when kids struggle with graphing is where they're placing their points. I also like to describe it. This is what I learned from my college professor, and it always stuck with me. So your y and your x, right? So let's say we're given the point 3 and negative 4. So this is going to look really awkward because it's right here and it just looks terrible. Because it's not a really good graph. I need really good graphing stuff, but I don't have good graphing stuff here. So I'm going to draw my lines. So the way that I learned this, and that I always love to repeat it, is first of all, to find your point, you have to walk to the elevator before you can choose to go up and down. So I have to walk 3 spaces, and then I'm choosing to go down 1, 2, 3, 4. So that's where that point is. I had to walk to the elevator, and then I chose what floor I wanted to go to. That's how we graph these points, because you always have to walk and then go up and down. Left or right, and then up and down. That's how I describe the graphing. And I like that. It's a really nice way to graph things. Okay. So now let's see if we can trick you up. Well, not really trick you up. It tricked a few kids up, but they did it to show what happens with slope sometimes. So, say we have 5, 3, and 7, 3. And we need to find the slope. Well, right here for me, I can see what the slope is. But we'll go through and we will find out for you. So I'm going to do 3 minus 3, 7 minus 5. Well, 3 minus 3 is 0, and 7 minus 5 is 2, and 0 over 2 is 0. So our slope of this one is 0. Okay? Well, what if we had something a little reversed? We had 3, 5, and 3, 7. Let's try this one. So now I have 5 minus 7 and 3 minus 3. So I should have negative 2 over 0. Well, let me tell you a story that my college professor also told me that has stuck with me forever, and this is how I describe these kind of situations. So in this story, you have to imagine yourself as a guy, obviously. Let's say you're out and you are out mowing the lawn on a really hot day. And you're like, you know what? It's too hot. I'm going to go take my shirt off. That's fine, right? No one's going to get mad at you for taking your shirt off on a hot day to mow your lawn. So you can take your shirt off on a hot day, which means you can have a 0 on top, which means your slope is 0. But say you're mowing the lawn on a hot day and you decide, you know what? I'm going to take my pants off. Cops are going to get called on you. You're going to get in trouble. So this we define as an undefined slope. Just remember, you can mow the lawn without your shirt on, but you can't do it without your pants. Do you see where I'm going there? I find that story funny, and when I tell it to kids, they're like, "You're so strange." I'm like, I know, but you'll never forget that. You can mow the lawn without your shirt, but you can't do it without your pants. That's my lesson on that part of slope. So, I know, I'm hilarious. What can I say? I make myself laugh. I'm funny. So now that we know the basics of finding slope, we have something called slope-intercept form. And slope-intercept form is y equals mx plus b, where m is our slope and b is the y-intercept. And the y-intercept is where you're starting on the graph. That's what that means. That's where you start on the graph. Y-intercept. That is not how you spell slope. Slope. Not the other. The brain did not want to break that. Anyway. So now that we have that, let's try to put an equation into this format. Because sometimes you're given an equation and they're like, please put this into slope-intercept form so we can graph it. So if I'm given this equation, 3x plus 4y equals 7. Basically what I'm doing is I'm just trying to solve for y. Y needs to be by itself. So let's get rid of everything except the y. Well, let's get everything attached to the y. So I'm going to minus my 3x. So I should have 4y equals negative 3x plus 7. Well, we still have to get rid of this 4. So everything gets divided by 4. So now this equation in slope-intercept form is y equals negative 3/4 x plus 7/4. That's not really a fun one to graph, but you see my concept here of moving things over, getting y alone. Now it looks exactly like this. So if we were to graph it, if it was a nicer one to graph without this fraction, it would look like an amazing line. That's what I'm saying here. I love slope-intercept form. I really do. People don't, and I'm like, why not? It's dope. So, now, let's see how one works out. Let's see how one works out to graph it. I know my graphs don't look amazing because I don't have graphing paper on the board, but I want to show you the concepts of it. So, if I'm given this equation, I'll just give this one equals 3x plus 5. Okay, so we're given ours in our equation already. We don't have to solve anything. Now we just need a graph. Not going to look as pretty as you want it to, but it is. Okay, so since this is my y-intercept, this means I need to go up to 5 on the y-axis. So 1, 2, 3, 4, 5. So I actually start here. This is where I put my first dot. Cool, right? Yes. That's where the first dot goes. Maybe I'm going to put it in orange. First dot goes right here. Cool? That's a little better. So now we just have to use our slope. Well, our slope is 3. Technically, our slope is 3 over 1. So what we're going to do is we're going to count from here, and we're going to go 1, 2, 3, and then over 1. if you want to, usually you really only need 2 dots to draw a line. But I will, for the sake of this graph, because it looks awful, we'll go down 3 as well, because you can keep going up, but I ran out of space. So let's go down 3 and back 1. And it'll work the same way. So we'll go 1, 2, 3, and back 1. And yes, this won't look like the straightest line in the world, but it's because it's on a really crappy graph. So this is this line graphed. I know. Someday I'll just get like a grid for this. It would be amazing. Cool, right? I love graphing. I really do. I like graphing a lot. So, knowing that we can graph easily now, let me check my book to see what else we need to cover in this. Alright, so this is going to be a little more difficult because you're not going to be able to really see, because sometimes you're given a line. This is hard when you're given. So if I'm given this line, start here, and just go like this. I'll make it easy. So if I'm given a line, and they're like, okay, I want you to find the slope. Well, the easiest way to find the slope is to find a nice point where it's passing through one of the axes, right? Well, I've got one right here. So I'm going to use this point, and I'm going to see how much I'm going up and over. You just got to count. So I'm going up 1, over 1. I made this one easy. And you go up 1, over 1. It should be, it's not on the best graph. So our slope on this one is actually just 1. They just want you to write the slope. You're just counting how far it goes up and how much it goes over. Because it's always rise over run. That's how we graph. It's rise over run. Change in y over the change in x. Rise over run. Really wish I had graphic stuff on this. So, knowing that, it's pretty cool, right? Right. Let's see. We're trying to go through and find out what we need. Here we go. So I know they taught you guys about the 0 and the undefined. Well, what does that do to our graphs? I'll show you. I will show you what a 0 and an undefined line look like. So let's say we have something that has a 0, right? Because if we have something that has a 0, so let's solve one first. Oh my lord. Okay, so if we're given a graph that looks like this, given an equation that says y equals 4, and an equation that says x equals 3. This is how we're going to graph these. Y equals 4. We're just going to go up to 1, 2, 3, 4. Put our dot. And guess what? A y equals 4 line. So horizontal line. This is a slope of 0. But an x equals 3 goes right there. And it is a vertical line. And if it says x equals 3, and it's vertical obviously, this is an undefined slope. And this is slope of 0. So if you see a y equals something, you know you have a slope, but it's a slope of 0. It's a horizontal line. If you see an x equals something, it's undefined, vertical. It's pretty easy. I'm not sure I like it. So there's another part of this called constant rate of change. But constant rate of change is exactly what slope is. So if we're given minutes and calories burned, so I have So if we're given minutes and calories burned, we have to find the rate of change for each of these situations. So we're given our time, and we wrote it like this, and we're given calories burned. Okay, and our first time was 40, and then 60, and then 80. And then we had 500 calories burned, 750, and 1,000. And our goal here is to find out our constant rate of change. Well, constant rate of change can be easily found by just doing the change in y over the change in x. It's super easy. I would like to use this as my y because it's on the bottom. It's not a y, that's a y. This is my x. So change in y over the change in x is super quick. So what I'm going to do is I'm going to do 750. I'm going to minus 500. And I'm going to do 60 minus 40. Sir. So I know that 60 minus 40 equals 20. If I can do math in my head, which I can't. And 750 minus 250, or minus 500 is 250. And then we just divide that by 20, right? So we're getting 12.5 calories burned per minute. Right? Yeah. Per minute. That's how many calories we're burning a minute. It's just slope. They just make it sound weird when they say constant rate of change. It's slope. They just put it differently when they're in a word problem. Because word problems like to mess everybody up. But I don't mind the word problems as much. That won't shut. So, knowing that we have that, now let's try to find intercepts. Oh, yes. Intercepts, finding them, are one of my favorite things. Because it makes graphing easier. We'll try not to graph as much anymore. But, so if we're finding intercepts, because it makes graphing easier when you want to find an intercept. So let's look at finding an intercept. They're going to give us an equation that's not in slope-intercept form. And that's fine. We don't even have to solve it in slope-intercept form. So let's say we were given 2x plus 5y equals 10. Okay? Well, I want to just solve for the intercepts. Solving for the intercepts means I'm going to take 0, and I'm going to plug it in for x, and then I'm going to take 0 and plug it in for y. Because when 0, so here's my x and here's my y. So when x is at 0, I want to know what y is. When y is at 0, I want to know what x is. And that will make my 2 points that I can graph off of. So let's say I plug 0 in for x. All I do is I cover that. Well, what is 10 divided by 5? 10 divided by 5 is 2. So now, let's plug 0 in for y. Well, what's 10 divided by 2? Well, that's 5. And those are my intercepts. So if I were to graph it, I swear I'm trying not to graph so much, but this is a graphing lesson. So when x is at 0, so I don't go anywhere, I'm not walking anywhere, I'm just going up to the second floor. And then this one, I'm walking over to the 5th elevator, but not going anywhere. And that is our intercepts. And that makes graphing easier. I mean, there's problems where you won't find a nice intercept. which is fine. And then you would have to put it into y equals mx plus b. But I like to use the intercepts when I know it's going to work out. And most of the time when you're given a worksheet on intercepts, they're all going to work out. And intercepts are easy because you're just plugging in a 0 and a 0. Oh, there it is. So, I like the intercepts. Let's try another one. And if it doesn't work out, it doesn't work out, and that sucks. But, you know, what do you do? So let's do 6x. Okay, so 6x plus 3y equals 36. Let's find our intercepts. I like to draw a t-chart when I'm doing these ones, because then I'm like 0 and 0. So when x is 0, y is going to be what? Well, 36 divided by 3 is 12. Well, when y is 0, 36 divided by 6, 6. Easy to graph. Awesome, right? Intercepts are easy. Let's see. Hang on, let's see what else is in my book. What about if we're given a table and they want us to find the intercepts using a table? This is so quick and easy, I promise. So if we're given a table like this, and we're given, well, this is my x, this is my y, and we're given like a 0 and a 3 and a 2 and a 4. This is not going to be, it's not going to have a constant rate of change, I'm sorry, but it's just not. Oh my. It's not going to have a constant rate of change. Okay. It won't have a constant rate of change, guys, and I don't care at all. I'm just trying to show you what happens. Okay, so it doesn't have a constant rate of change. Let's just ignore the fact that I didn't make one with a constant rate of change. I just want to show you, if you're looking at a chart like this, and it's like, well, find your intercepts. Well, that's easy. I already found my x-intercept, and then I just found my y-intercept. You just look, or this is my y-intercept. You just look where the x is 0. So wherever x is 0, that's your y-intercept. So y equals 3. Wherever y is 0, that's your x-intercept. That's it. So if you're looking at a chart and they're like, find your y and your x-intercept, look where you see the zeros. That's all you have to do. That's easy. So exciting. Math is exciting, right? Math is amazing, guys. So, most of this stuff is all graphing, which is nice. So, if you really want graphing, I can graph more. Just let me know in the comments. I know the graphing kind of sucks on my whiteboard. But tomorrow, we will go over functions. So tomorrow's fun thing will be on functions. You have that to look forward to. Oh my goodness, functions tomorrow. They're easy functions. They're not really hard ones like I had to do in college. So that's tomorrow's lesson. Today's was slope, and slope is fun, guys. Hopefully you're enjoying these and getting stuff out of it. Leave comments if you want to see other stuff. So that would be amazing. Hopefully you're getting help.